Section 4 is on solving exponential logarithmic equations. There's two main strategies in doing this. They are one-to-one properties, which you'll see here. If two bases are raised to the same power, then the powers must be equal. And a similar thing with the logarithms, you'll see those relationships there. The other method is inverse properties, and that's something that might require a little bit more thought. So basically, what I've got here is just a bunch of different equations that we can look at and solve together, taking advantage of everything that we've learned up to this point, basically. So the first one here, e to the x power is equal to 60. When we see something like this, we got to keep in mind that what we're allowed to do is we can take the log of both sides, and I'm going to use common log. You can use natural log, it'll work just fine. I'm going to write log of e to the x is going to equal log of 60. That's true based on the property right here. If two things are equal, then the log of with the same base of both of those things are going to be equal as well. And so that's what I've done here. I'm taking log 10 of two things that were equal to begin with. What this allows me to do now, using exponent rule, the x can come out in front. I have x times the log of e is equal to the log of 60. Now don't forget, e is not a variable, it's a number. So we have x is equal to the log of 60 divided by the log of e. And for that, we can just type that into our calculator, and we will have x. So I need to do log 60 divided by log e. To get e, I have to enter it as e to the first power on this calculator. We got about 4.09. Second one here, we'll make that look similar. What we can do to get rid of the 7 first off, so that we have just 3 to the x, we can divide both sides by 7. And again, I encourage always pause and try to move forward on a problem, and then resume it and see if you've done the right thing. From here, we're gonna do something similar to what we did up here in the top one. So I'm going to take the log of both sides. Log of 3 to the x is going to equal log of 5. Exponent rule allows me to move that exponent out in front. So x times the log of 3 is equal to the log of 5. So I'm going to get my x by taking the log of 5 and dividing by the log of 3. This is going to be approximately equal to, I accidentally put an equal sign. Oops. Important to note, I am going to be rounding. So we do the log of 5 divided by the log of 3. You can do that in your calculator. You get about 1.46. Okay, similar thing here, just we're gradually getting each one to be a little bit more involved. What I'm going to do here is I'm going to first add 6. Then I'm going to divide by 3. I'm going to have 5 to the power of 2x plus 1. And that is all implied to be the same power. I meant to clarify that up here, but hopefully you understood that. This is going to equal 15 divided by 3 is 5. Now we can proceed here the way that we've done in the other problems. However, we should notice both this is 5 to a power equals 5 to a power. Well, this over here is 5 to the first power. So what I know in this case is that 2x plus 1 has to equal 1. 2x would equal 0, x is going to equal 0. Okay, we got a similar problem down here. I'm going to subtract 4. When I do that, that's going to give me 35. And I'm going to divide by 7. So I'm going to get 4 to the power of 3x plus 2. And that is going to equal, what did we say? Subtract, that's 35 divided by 7 is 5. So I have 4 to the 3x plus 2 equals 5. I can do the logarithm thing. I'm going to skip a step here. That's going to be 3x plus 2 will eventually be brought out in front times the log base 10 of 4 equals the log base 10 of 5. So I've got 3x plus 2 is equal to the log of 5 divided by the log of 4. So this, let me just show in my calculator here what I would do. First off, we're going to type in log 5 divided by log 4. It's going to give us a decimal, no doubt. Now that decimal is what 3x plus 2 is equal to. So I'm going to proceed as if I had that decimal written in place of this. What would I do to solve? I would subtract 2. And that I would take and divide by 3. So I'm going to have an x value of approximately, what did we say that was? Negative 0.28. Okay. I don't know what I did here. I must have forgotten to erase something. Sorry about that. Okay, so here we have e to the 2x minus e to the x minus 6 is equal to 0. This is a problem that you will see these pop up. And what this is, our intention here is for you to recognize this as a quadratic. So I'm going to rewrite this problem as e to the x squared. That's the same thing as e to the 2x. Remember your exponent rules. Minus e to the x minus 6 is equal to 0. We're going to try and factor this. Just imagine this says x squared minus x minus 6. Well, if it said x squared minus x minus 6 is 0, we would be able to factor this as x minus 3 and x plus 2. So over here, this is going to factor as e to the x minus 3 and e to the x plus 2. Double check the FOIL. Make sure it does take you right back to where you were here. Okay. Well, now we know that if this product equals 0, e to the x minus 3 would equal 0, and e to the x plus 2 would equal 0. So this one gives me e to the x equals 3. This one over here gives me e to the x power equals negative 2. Now, since we're dealing with e, it's going to be beneficial for us to use the natural log instead of the common log. So I'm going to take the natural log, which don't forget that means base e, of the left side and the right side. Now what happens here, this is, don't forget, it's not written, but it's base e. So e to some power equals e to the x. Well, that is going to equal x. That's one of our inverse identities from the first slide. I just realized I didn't write it, but actually I did. That's basically what this here says right here. I just didn't write it with natural logs. So continuing on here, I just type in natural log of 3 and I'll have this. So I have natural log 3, enter about 1.1 is what that'd round off to. So approximately 1.1. That's that one. So pause it and try this one real quick and then resume it. Natural log of both sides. This is going to equal x. So the natural log, see what the calculator gives us. The natural log of -2 is an error because we cannot take e to the power, e to any power and get a negative number. So we're going to say we have this. Number 6 here, natural log of x is equal to 5. We're dealing with a natural log again. So I'm going to take advantage here of the inverse identities. I'm going to take e to the power of the natural log of x. Well, if natural log of x equals 5, this should give me the same thing as e to the 5th power. So think about this here. This is natural log base e of x. So this says e to the power of whatever this is equal to will give me x. Well, I'm taking e to that power, so I am going to get x. And then I just go to my calculator and I'll ask it what is e to the 5th power. So e to the power of 5 is approximately 148.41. And once again, I keep forgetting to put approximate signs, but these are approximate answers. They're not exact. Number 7 here, this last one before I end this video probably, since I have both of these are log base 7, so log base 7 of something equals log base 7 of something, well that means that 8x minus 3 has to be the same thing as 6x plus 9. So I solve this one ordinarily just like a linear equation. So subtract 6x, add 3, divide by 2. Okay. Let's take a peek at what we got next here. So I think I will pause this video. We will resume right here.